In the last video, we looked at how to take a system of linear equations and write it as a matrix, and then how to manipulate that matrix by hand to find the solutions. And I said that I would not on a test enter the calculator or the computer. So this is all, it seemed like almost more work to do it by hand using a matrix than just to use the addition method, the elimination method. And for the most part, it is. With computers do that basic skill of multiplying and adding very, very quickly. And so it makes it a lot faster. So going back to our cereal question from the beginning, we've got Cheerios, Cinnamon Toast Crunch, and Rice Krispies. So C was Cheerios, T was Cinnamon Toast Crunch, R was Rice Krispies. To remind you, we had a very specific spring break diet or something like that. And we had to have exactly 245 calories. So these are all the calories per serving of the different cereals. We have exactly 245 calories for breakfast. I believe this was sugar. We're gonna go with sugar. I can't remember exactly. I have to double check. And I think this was fat. 2 grams of fat, 5 grams of fat, 2 grams of fat. And if I'm wrong on those, I have the labels on my solution in the end. But so this is what we're looking at. And these are the different serving sizes of each that I needed to have. So let's take this system of equations that we wrote and put it into a matrix. So looking at the matrix, we'd have this. We'd have all the Cheerio serving sizes. We got 120 calories per serving, 4 grams of fat, 4 grams of sugar, or 2 grams of sugar, or vice versa. Toast Crunch and Rice Krispies. So again, they do all need to be on a line because this column here represents one variable. Second column is another variable. And the last column here was the solutions. And I want to solve. So I'm going to get into this reduced row echelon form. And this is where if you have a handheld graphing calculator, pull that out. If you are using an emulator, online emulator, get that ready to go too, because we're going to learn how to input this into a calculator and have it solve it for us. And we wanted to get a 1 in the diagonal here. 1 C, 1 T, and 1 R, and 0 everything else. That was the goal. Okay, moving over to the calculator then. So I'm going to turn my calculator on, and matrix. So matrix on the TI-83 Plus, and I believe it's in the same spot for the TI-84 and the TI-84 Platinum or Titanium or whatever. It should say matrix somewhere over here. So MATRX, we got matrix right there. Mine's yellow, so I'm going to click the yellow button first, and then this button for matrix. And then I have all these different matrices that are built in, but I need to edit them. I need to put some numbers in. So I'm going to go over to edit. We'll come to math later, but we're going to go over to edit. So we're scrolling over to edit, and I'm just going to use the first one. We want this to be a 3 by 4 matrix. If you forget the order, that's okay. Just change it back. What I mean is if you go, well, was it 3 by 4 or was it 4 by 3? If you do 4 by 3, you get 4 rows, which is just too many. So go back and change it. It ends up being a 3 by 4 matrix. And we're just going to enter those numbers. So I'm going to have 120, the first one, 130, the second one, 105, 245. I'm just pushing enter. So I'm doing this on my keyboard, but you do 4, enter, 3, enter. Here, there's no number, but it'd be like 1R. We have 1 and 6. 2, 5, 2, and 7. All right, so I entered all these numbers into my matrix here. What you need to do next, if you need to pause it and fill that in yourself, go for it. But what you need to do next is you need to quit. So we're going to quit out of this application. So you can do second, quit. That is important. It seems like it's an extra step, but you do need to quit to make this, this computer work. We're going to go back into the matrix. So we're plugging back into the matrix. Now we have a matrix A. It's my 3 by 4 matrix that I have. I want to do some math on this matrix. I want to apply some mathematics to this matrix. So I'm going to scroll over to math. And I'm going to scroll down until I see RREF, reduced row echelon form. You'll notice there's an REF, different than REM, which is reduced echelon form. We want the reduced row echelon form. There's all sorts of other things you can do. You can do a row swap. You can do a column swap. You can do all sorts of different things. We're going to do reduced row echelon form. And right now it's doing the reduced row echelon form to nothing. So I need to put whatever matrix that I want this to be applied to. So I need to go back into the matrix, second matrix, and I want to apply it to matrix A. So I'm going to select the matrix that I'm going to apply it to. We'll do that one more time, a little bit quicker, just so you can see it again. So you go matrix, math, scroll down to reduced row echelon form, and then we're going to select the matrix that I want, matrix A, and I'm going to push enter. And here we have it. I've got 1, 0, 0, so I've got 1 Cheerio is going to give me 0.6 repeating, which is 2/3. I've got 1 Cinnamon Toast Crunch, gives me 1 serving of Cinnamon Toast Crunch. And I've got 1 for the Rice Krispies, gives me 1/3 of a serving Rice Krispies. There is a way to change this to a fraction. If you happen to know that 0.6 repeating is 2/3 and 0.3 repeating is 1/3, that's great. But if you click on, at least for the T83, if you click on math, right here it says fraction. If I push enter, I can take my answer and change it into a fraction. Whoa, there it is, 2/3, 1 and 1/3. I've got my solutions. So that's using the calculator. The calculator doesn't tell you what this means, of course. I need you to be able to interpret that. And so once you've done this reduced row echelon form, I'm going to go back to my presentation here. So you put it into a matrix. I need you to be able to label those answers, because just putting it into the matrix and pushing equals doesn't require a whole lot of thought. But I need you to be able to interpret that and say that the first row there was 2/3 servings of Cheerios. The second one was 1 serving of Cinnamon Toast Crunch. And the third said 1/3 serving of Rice Krispies. So interpreting that matrix, that solution in reduced row echelon form is an important piece. So I need you to be able to label those answers. Let's do another example. Okay, collection of nickels, dimes, and quarters. We've got 15 coins total. We don't know how much of each. We have 15 coins total, and they all add up to $1.10. We also know that the number of nickels is 1 less than 4 times the number of dimes. I'm going to be perfectly honest. Those sentences right there seem very contrived because most people don't speak in that way. The number of nickels I have is 1 less than 4 times the number of dimes. But that you're going to see it a fair amount. So we'll practice with it. We want to know how many of each coin. There's 2 things going on here that are, well, 3 things, I guess. But one of them is fairly obvious, the equation with the 1 less than 4 times the number of dimes. That feels like an equation right there. The $1.10, that involves an equation because we're dealing with money now. 5 cents, 10 cents, 25 cents. What seems to throw people the most is the very, very, very first equation. And the very first equation, remember we need 3 equations for 3 unknowns, nickels, dimes, and quarters, is that this 15 here. We have 15 coins total. That means that all the nickels plus all the dimes plus all the quarters has to be 15. That's an equation right there. One thing that I want to caution you on is this 15 has nothing to do with money. This 15 has nothing to do with value of the money. All it has to do with is the quantity, how many nickels, how many dimes, how many quarters. So when you write this first equation, it should look like this, that the nickels plus the dimes plus the quarters equals 15. No, there's no dollar amounts involved here because 15 has nothing to do with dollar amount. So you've got one nickel, or some number of nickels plus some number of dimes plus some number of quarters equals 15. Okay, now let's deal with the money. So now we've got this, or the dollar amount, the value, we'll say, sorry, the value of that money, that $1.10. So the way I'm going to write this is I'm going to say, I know that nickels are 5 cents each. So for every nickel that I have, I should do times 5 cents. Every dime that I have, I should do times 10 cents. Every quarter I have, I should do times 25 cents. And when I do that, I should get a total of $1.10. So I'm going to write it like this. There's one other way to write this second equation, and that's if you basically multiply everything times 100 and say it's 5N, 5 cents for every nickel, 10D, and 25Q. If you do it as whole numbers, not decimals, 5N, 10D, 25Q, the one thing you have to remember to do is to multiply your dollar amount times 100 as well. Because if you use 5N, 10D, and 25Q, that's 5 cents, 10 cents, 25 cents. This is not 1.10 cents. This would be 110 cents. So you just have to move that decimal over 2 for each of these. And that's one other way you could write it. I'm going to leave it as it is right here. So those are the first two equations, one dealing with the quantity, one dealing with the value. Now, the contrived sentence here, if the number of nickels is, typically in math is means equals, so that N equals 1 less, so I'm going to be subtracting 1, then 4 times the number of dimes. So that would look like this. N equals 1 less, minus 1, 4 times D. Now this last equation here, while correct, doesn't really lend itself well to a matrix because I don't have my variables all lined up. We've got QQN, which is wrong. So I'm going to shift this. I'm going to bring the N over here. I'm going to subtract 4D, and then I'm going to leave this minus 1. You could add 1, but it's not a Q, so I guess never mind. You couldn't bring this 1 over here because it wouldn't line up with the Q's. We have to leave this negative 1 over on the right-hand side here. It look like this. If you don't have any Q's, you have 0 Q's, you have 0 quarters. And so you can always put in 0 of something. So you can always fill in a spot if you need a placeholder with a 0. Okay, so this would be my system now. I've got three unknowns, 3 equations. I can put this into a calculator. Looks like I lost my first 2 equations, but that's all right. I remember how to do it. So I'm going to clear this off. Go back into the matrix. I'm going to do this a little bit faster now. I'm going to edit. I still have a 3 by 4. I'm just going to edit my matrix. It was 1 nickel, or 1 quantity of nickels, 1 quantity of dimes, 1 quantity of quarters, gives me 15 total. So again, that last one was 15. I'm just entering those numbers in. 5 cents, 10 cents, 25 cents, call it 10. And then it was 1, and -4, and 0. One thing I'll say, if some of you are using the emulator, the minus sign, if I do -4 on my keyboard and push enter, I get an issue. It doesn't like that. So negative numbers, you do actually have to click the negative to make the calculator like you. And -1. Okay. Again, I'm going to quit. And I'm going to go into the matrix, and I'm going to do reduced row echelon form. If you need to put this on like half speed, so I'm talking too fast, go for it. And I'm going to go back into the matrix, matrix A. There we go. Reduced row echelon form. I've got my solutions. I'm good for the nickels. I'm going to have 11 nickels. For the dimes, I'm going to have 3 dimes. And for the quarters, I'm going to have 1 quarter. So reading that matrix, 11, 3, and 1. 11 nickels, 3 dimes, 1 quarter. And I labeled those answers. So that's how you use the calculator to do that reduced row echelon form to solve these systems of linear equations much faster than we're doing it by hand.